Okay, the test is Sue said 84. 84 is logarithmic differentiation. There were two big reasons why you would take the log before you differentiate. What are they?
Variable in the exponent.
When you have a variable in the exponent. Now, let me pause for a quick word of warning. One year I gave this problem. Y equals x to the x, find dy dx. It went very well. Now, the next year I made a slight change. I didn't think it was a big deal. I said, find the derivative with respect to x of that. Pretty much the same, right? And yet, the success rate on this was around 95%. On this, more like 50%. Why? Well, yeah, it's not an equation. People say, okay, I take the log of both sides. But here, know both sides. What do I do? Well, you make it both sides, for Pete's sake. You say, okay, well, that is y equal x. So you can take the log of both sides. You have to think a little bit, all right? It's not going to just be all pretty princess for you. Are you with me? Okay. So if you have a variable in the exponent, you take the log of both sides, bring the exponent down, and then use implicit differentiation. Log, then implicit. Does that make sense?
Yeah.
Good. Okay, what's the other case for logarithmic? Well, it's the other case. Think of it as the anti-n case. At least that's how I think of it as the anti-n case. Is big ugly. Okay. Now, if you have something like a product of some huge expression and quotient mixed in, something like this. Let's go for 4. Well, that's terrible. I don't want to use product quotient rule. Oh, that would be terrible. And on a test where the time is limited, would not seeing this as a log problem be very costly? Yes, it would. You just lost 5 minutes. Okay? Instead, you take the log of both sides. The purpose being what? Why does that help you? You can separate to make it a sum of individual log arguments. Log rules allow you to take that log of this product and say log plus log plus log minus log. Anything that's in the numerator is plus, anything in the denominator is minus, yeah? Don't forget that on the test, you must write it well. No quote, quote, no leave y. You know what I mean? Write it well. Do not leave y. Replace y with the original. Okay, that's logarithmic. It usually goes well. Hyperbolic, I will expect just kind of a basic level of familiarity. I want you to know Cauchy's definition. What is Cauchy exponentially? Plus. Cauchy is plus, sinh is minus. Subtraction, negative. Okay?
So we don't need to know like hyperbolic, secant.
No, I'll stick to just those two. I do want you to know the identity. Cos squared minus sinh squared is 1. I do want you to know the basic derivatives. The derivative of cos is sinh, and the derivative of sinh is cos. Okay? With those and being able to apply them, so if in my mind, I would be on fine terms if I said, hey, what's the derivative of this? Let's go 1 minus sinh squared. So in my mind, that should be fair game, yeah? Because that requires you to know the derivatives in order to use of it. You need to know the derivatives to anti-differentiate. So. Okay, I'll pause and say this. It should by now be clear that questions often involve two concepts or more. Right? If you look at an AP test and look at 45 multiple choice questions, roughly 25 of them are combinations of two or more skills, not just one skill, but two or more skills. All right, that's to be expected. All right, integrating even powers of sine and cosine. Surely you would need to know or study the power reduction identities. If you have sine squared, to integrate it, you reduce the power by using the identity. Sine squared is? Okay, now I'm using u because generally it's just the angle. Whatever the angle is in the square, it's double that angle when you replace it. So if it was sine squared of 3x, then over here it would be cosine of 6x. Okay? What's the cosine squared identity? It's 1/2 plus. It seems like cosine is always plus again, just like before in the cos it was plus. Okay. Okie dokie. Differentiability. You need to, in terms of just studying facts, you need to know the 3 violations of differentiability. What are they? Discontinuity. Does continuity imply differentiability? No. Does differentiability imply continuity?
Yes.
Yes. All right. That's one. What's another violation of differentiability? Sharp turn. That could be a corner or a cusp, depending on if they're linear or curving. And vertical tangent. Notice he said vertical tangent, not vertical asymptote. Why not vertical asymptote? Discontinuity. We got that. Vertical tangent is bad because if the derivative is the slope, and the slope is rise over run, and it's vertical, then it's rising, but not running, and that's a 0 in the denominator. That breaks math. Okay? In terms of the types of problems of differentiability, I covered in your notes, there were 2 types. I said basic multiple choicey kind of, given f of x is something, plus 2, and bx plus whatever, 1 here. If I say find, and I would underline that, find a and b so that this is continuous and differentiable, then I'm not going to be too particular about your, just find a and b. If you take little shortcuts in notation, I'm okay with that. But if I ask you to show or prove that a function is not differentiable, then it's expected that you go very by the book, use limits, and especially for the differentiability, use the alternate definition of the derivative to prove. There is one on the practice. The other class said, I don't know what you mean, so I had to give them a little more. Do you understand what I mean, or do you need a little more specific example besides the one I gave you for practice? What?
Like what's the alternative?
So it would be something like this. If I gave you this, say I gave you 2x squared plus 1 and e to the x d of x. Okay, and I said maybe prove this is continuous but not differentiable. I assume the continuity part would be fine. We would make use of limits and show that the point is the same as the one-sided limits. That would be okay, yes? Mm-hmm. The alternate definition would be different. When you go at this curve would look something like parabolic and then exponential. Yeah. Okay. Parabolic and then exponential. Now, looking at that, it looks like it. My graph is kind of weak, but it looks like it. Maybe it is locally linear. I don't know. Prove. Now, when you prove the derivative doesn't exist here, remember the alternate definition says take a point of interest, 0, and another point on the curve, draw the slopes between them, and then take the points closer together. That is the part of the derivative. Slope between 2 points becoming slope at a point, right? Now, if I did that on this side, it might be different than if I took the other point on this side and drew the slopes and saw what happened with the approach. That then is the question is, when I say the derivative at 0, excuse me, is the limit as x goes to 0 of f of x minus f at 0 over x minus 0, that means the limit of the slopes has to be the same on either side. When I take the second point on either side, the slope should approach the same thing in order for it to be locally linear or smooth here and no sharp turn. Well, I would then need to go into the one-sided limits. What happens to the slopes if I approach from the left? Well, if I approach from the left, I'm using the parabola. So this would start to look like 2x squared plus 1 minus 1 over x. And I would find that limit. I imagine it would look something like 0. Yeah? I could then say, what about the slopes from the right-hand side? If I choose a other point on the curve on the right-hand side, then instead of the parabola, now I'm using the d function, e to the x minus 1 over x minus 0. That's 0 over 0. What does that mean? 0? No, 0 over 0 is not 0. We know 0 over 0 is indeterminate, right? So what would you do? You would do L'Hopital. This, therefore, would be the same as e to the x over 1, which is 1. The slopes on the right want to be 1, but the slopes on the left want to be 0. If you zoom in on enough, it would look like that. Because the limit doesn't exist, the derivative doesn't exist. That's what I expect you to be able to do. Is that clear? Okay. Volumes of washers are pretty good. Just heading off 2 big mistakes. First of all, forgetting the part. Don't forget the part. Second, washers is big R squared minus little r squared. Not big R minus little r quantity squared. There's a big difference there. It is a bigger circle minus the little circle. And you find the big circle by doing pi r squared first and then subtracting radius. Okay? For the most part, that goes well. Moving on. Rational functions, I expect you to be able to find a slant asymptote. I will not expect you to find a parabolic asymptote. It might look one of 3 ways. This, or that. If I asked you to find the slant here, how could you? What's the easiest way? Just what? Split it, yeah. Okay, once you have that, then you have something like 2x plus 1 over x. This is the remainder. The idea is that x gets infinitely large, the remainder goes to nothing, and it starts to approach a slant of r equals 2x. This, because it's not just plain x, it's a little more complicated. How can you find the slant? You can synthetic divide. Can you also long divide? Sure, long division always works in every case. Okay, what about if the divisor is nonlinear? It's long division only. Do not use synthetic because you might not even have real roots. You don't want to divide by pairs of irrational or imaginary roots. You don't want to go there. Long division. Okay, L'Hopital's rule, make sure you show it's indeterminate before. Do not assume. There's a problem on the homework. Look like that. People say, okay, here we go, L'Hopital, boom, limit is 1 over x. What's the problem with that? It's not indeterminate. Okay, what does x go to? Small positive. What does natural log x go to? Negative infinity, huge negative. That's not indeterminate. That's not I don't know. I know. Small number divided by a huge number is 0, period. It's not indeterminate, okay? All right, so just don't assume the minute you see an infinity or the minute you see a 0. Here we go, Lobito. Take it first. Yes?
What happens if it's negative infinity or negative?
It's still a Lobito. Sorry, I didn't specify, but it's also a Lobito. Okay, position, speed, velocity, acceleration. I gave you an AP problem in the practice. That'll be good. How do you show speed is increasing? Velocity and acceleration have same sign. They work together. You're moving right, you push right. You're moving left, you push right. Distance versus displacement. Distance given velocity, how would you find distance? Absolute value or integrate? Absolute value. How do you find displacement? V. Just V, I don't care. I want to know, is it moving right or left? What if velocity is positive, then they are the same. You should say so. Okay? If the velocity is positive, then the absolute value of V and V, same thing, right? I mean, the absolute value of positive is positive, no difference. So it's the expected. If I tell you, hey, the velocity is always positive, what does this mean? And you can say it's the displacement from time 1 to time 2, but you should then add, because velocity is positive, this is also the distance. That's an AP style. Okay?
What's the word after positive?
Oh, come on.
Some?
Same. Dude, that was obvious. Say so. Okay, last but not least, work in pumping fluids. Work is, don't get it confused with force. Work is fluid low to fluid high. That's just like force, actually. They're both just about the fluid. I don't care about pumping fluid where there isn't fluid. It's about where the fluid is, right? It is rho, distance, where you're pumping it, not depth. Because it's distance, it's usually to the top of the container, not to the surface. And the volume of each slice being pumped. Now we typically, in Saxon, he often does rectangular problems. But what if you had a barrel on its circular base? Then in that case, the volume here is length width height. Cool. But here, what's the volume of the slices being removed? So don't assume that it's always just some rectangular sheet being moved. You have to take the case by case. Okay, that is that. Be ready. Kill that baby. Let's move on to differential equations, shall we? You will, hopefully, go on to take UPQ. It's so cool. I mean, you'll be given problems like the temperature in the room was 35 degrees. The temperature of the dead body was 17 degrees, or 72 degrees. How long has he been dead? That's differential equation. It's so cool. You will love DiffEq. When I say DiffEq, obviously, that is shorthand for differential equation. You love DiffEq, everybody calls it DiffEq. We're going to do separable differential equations. Non-separable is for your differential equation teacher to teach you. And we'll go at this a couple different ways. Usually there are about 3 lessons on this. This is usually a new chapter in a book. Differential equations is its own chapter. So this is the white page chapter. And I'm running out of colors, obviously, because there's only those colors in the copy room. I'm either going to not teach that other stuff or try and figure out some paper condition here. All right, so here goes. Differential equations. A lot of this will build off things you know, but be slightly different. Just gradually segue into different, all right? A differential equation is an equation of the derivative where there are differentials. dy and dx are differentials. They represent infinitesimally small changes in y or x. Now they usually come in a derivative form, a comparison of the change in y with respect to changes in x. So you will get, when you get a differential equation, it'll almost always be written in derivative form like that. When it says solve the differential equation, that means you are supposed to go back to find the original y-x equation. And that little bit of vocabulary is crucial because I had at least one person come up to me last year. She needed to do well on the test. She got to this question and she blanked. She said, "What does solve mean?" Now, I mean, that's solve. Nobody knows, and nobody screws up what solve this means. You know, everybody knows that. But when you come to this and it says solve the differential, what do you mean solve? What am I solving for? Solve in this case means go back to the y-x equation. Got it? All right. Now, other thing, this is also so sad for so many people on AP grading here. The very first step, would you please put the old steps here and write the first step. The first step is to separate the variables. Write that, please. It's very important. In fact, so important that you should underline. And then you should also put stars around it. And then you should put a big arrow and say, do this. Because you're about to, on problems in BC, when we do a logistic equation, it'll take a page. And it's roughly about 23 steps, 25 steps, somewhere in there. Okay? And if you don't do that first step, put a 0 in it and pass the step. Don't do it. The AP instructions are, if no separation of variables, 0. Pass the step. Yep, immediately. They do not even look at it, no matter how beautiful your calculus is. If you neglect to show the first step, then you're out. You're just out. Well then, now that I set the stage, you probably want to make sure you understand what separating variables means. It means you put y's and dy terms together on one side, and all the x dx terms on the other side. If you have a constant in there, it can go on either side. That's not an issue. Okay, separate the variables. It doesn't say anything about the constants. So in this case, I'm going to rewrite this because it's not in math type. I hate the way that's written. dy dx is x over y. So if I separate the variables, I want y's and dy's together. So I'm going to multiply y over there and get y dy. And I will multiply dx over, and I'll get x dx. Please write yourself a note. dy and dx are always in the numerator. If you get a dy or dx in the denominator, you did something wrong. You best fix it because you are a deep duty. Okay? Y dy over to x dx. Now, if you're supposed to now go back to what the y-x equation is, then surely you're going to get rid of the differentials by integrating. Integration is an algebraic process, in a way, in a fashion. So whatever you do to one side, you must do to the other. I cannot just integrate one side, I must integrate both. Now you can do that in the same step or same line of your work as a separation of variables. That's okay. It doesn't ruin your separation of variables. No big deal. What is the antiderivative to the left? 1/2 y squared. And on the right-hand side? X squared over 2. Now, I heard plus c. That's delightful. it is not the expectation that you show the constant of integration on both sides, because the next step you do is put the two constants together and get a totally different third constant. It is not required that you write plus c on both, plus c on one side only. It's arbitrary. You would put them together anyway to get a third arbitrary constant. One's fine. Are we cool? Okay. If the problem does not say, I'm sorry I didn't write these notes in here for you. I was just right behind today. If the problem does not specify what form, you may leave it as it is, okay? I just solved the differential equation. I got a yx equation. It's there. It's done. I answered the question. However, if they specify, if they say something like y equals f of x, or you want to recognize a graph, you might change it. Now, for example, here in B, they say sketch possible solution. Now, I kind of know what's there, but I would know better if I cleared the fractions. I just said it's arbitrary, but I call it 2c. Now, in DiffyQ, C versus 2c, if you've already put a point in, then there's a difference, and it's not arbitrary. So I'm going with 2c. It's safe. Okay. I still don't really feel it. I don't really know it. And so I'm going to do that. Now I know it. That seems to look like a hyperbola. Okay. It is indeed a hyperbola. In fact, I actually misspoke. It's not a hyperbola. It's an infinite family of hyperbolas. This is called the general solution. All right. Now, if I were to sketch this, let's do a few possibilities. Say C is a half. What's the graph? Is it open side to side or up and down? Y squared minus x squared equals 1. Opens. Whatever. Up and down. You know what I mean? Where's the vertex? Where are the vertices? 0, 1, and 0, negative 1. Remember when you go to graph hyperbolas, they're quasi-linear, not parabolic. They follow linear asymptotes. Hi. What if you had a C of 2? Then it would still be vertical, but the vertices would be at 0, 4, 0, 2. Maybe 0, 2. Square root wise, you know what I'm saying? Yeah, square root 1. Okay, so it would be something like this. And I could continue. Now, let me throw something out at you though. Are you sure it has to be vertical? In what case could it be horizontal? If C is negative 1/2, if C is negative 1/2, then this is negative 1. If I divided negative 1 over, then it's a horizontally opening one. So there's a lot of gray area in differential equations, and you get a whole family of possible solution curves that it could be. You follow? Kind of cool looking, yeah? All right. If they give you an initial condition, then you can find the single curve. For example, if I said, yeah, it has this differential equation, but it also passes through 3, 5. Well, then it narrows it down to one possible curve. Actually, it would be in its compatriot. But so to find that, then that implies you want to find the C. Particular solution is the exact solution to that, find the C. So if you plug in the condition 5 for y, 3 for x equals 2c, I get that 25 minus 9 equals 2c, so 2c is 16. I actually want 2c. I don't really care about c. I want 2c so that I can write my final equation as y squared minus x squared equals 16. That's the particular solution, the single solution. So far, so good. Okay. This is pretty common on your homework, the Saxon book. It is happy to do relations, curves, circles, ellipses, whatnot. On the AP test, and just generally college classes too, they often go at it a little different. So this is part of an AP question. Differential equations are pretty darn common on the AP test. Out of the 6 questions, it's usually 1, 90% of the time. So it's a pretty good bet to be on it. This piece here, out of 9 points, is usually 5 or 6. It's a big deal. So, would you consider walking through this with me together, and let's make sure we do this well, then you'll try one on your own. So you have the differential equation, and right away I would probably rewrite this so that negative is attached to one or the other, but not up front. That's good to me. Okay, so we're supposed to find a particular solution. Solution means I want to integrate to get the yx equation, and particular means I need to find the plus c, right? So, what's the first thing I should do? Separate the variables. When I separate the variables, what do I get? Y dy equals negative 2x dx. Okay? At that stage, then I want to integrate. So I'm going to integrate both sides. The left-hand integral is, or antiderivative rather, 1/2 y squared, and the right hand, negative x squared plus c. It's recommended, and just easier to do, if you use the initial condition right away. So if I plug in the initial condition was if x is y, the result is negative 1. So 1/2, use parentheses, negative 1 squared equals negative 1 squared plus c. I get 1/2 equals negative 1 plus c, which implies c is 3/2. Put that into your general. So that I now am at 1/2 y squared equals negative x squared plus 3/2. Am I done? Yes. Okay. There is a tip in here that tells you you're not done. What is it? Yeah. They say solve for y. You are supposed to solve for y. So do so. If you move the 2, you get y squared equals negative 2x squared plus 3. Square root, you get plus or minus negative 2x squared plus 3. Sweet. Done? No, not done. What's wrong? Plus or minus. Yeah. It says y is plus or minus. So when I put in an x of 1, how many y's? 2. What do they ask for? They ask for a function. They don't ask for 2. They don't ask for a relation. They ask for a function. What is the single function that passes through? It must be a function. You must choose. Show plus or minus, so you establish, hey, I know how to do algebra. But then you choose. Based on the initial condition. Now why, yeah, when I say choose, it's not like, hey, I feel like nature. It's to choose the one that makes the initial condition. What forces the initial condition? Well, if when x is 1, y is negative 1, the only way that's going to happen is if I choose what output? Gotta be negative. Okay, so that is your final solution. It's the single function that generates, single function that generates the initial condition. It's important to understand that if you don't put the plus or minus and it just happened to be plus, you don't get that point. You don't get a point for being lucky. Okay? I'll do this on an AP style later, but right now, just so you're clear, free response questions are 9 points on the calculus. Okay? There are 6 of them. This would be a huge chunk of points, and look, strategy. 1 point here for separates variables, and there would be a note off to the side, no separation of variables, stop reading, 0. 1 point here for integrates. 1 point integrates correctly. Now that's probably both sides. Sometimes that's even 2 points for integrating both sides. Okay? Easiest point of all time, 1 point for constant of integration. Say you're just having a terrible day. You cannot, whatever, you hit your head on the way to the AP test and you are not drawing a blank. If you separated the variables, didn't know how to integrate, and you said, I have no idea on the left, and your mom wears combat boots plus C on the right, you get a point because you put plus C. Legit, I'm serious. Okay? If you put plus C at the end of whatever, you get a point. Constant integration. 1 point for uses the initial to find C. Now, depending on the year, notice the wording here. It doesn't say uses the initial correctly. It just says uses it. You put it in somehow. Okay? They're pretty generous here, man. You can pick up 3 points being really clueless calculus-wise. Just by saying, I know I need to separate the variables, which really an algebra kid could do. That's not hard. Know I needing to put plus C, and knowing that you needed to put the point in somehow for the x and the y. After that is the hardest point is to solve for y. All that is 1 point. So, okay? But that's what separates the good from the great, which is what we will do. Try one on your own, please. Try that one. This one's a little different. It should still have a plus or minus component to it. You'll see. No, f of x is, so this is the x, this is the y. That's okay. Oops. Oops. Check your work so far. That's where most people got to successfully, and then I will say this while you're finishing. Log happens a lot in problems that we're headed to, logistics especially. If you fail to use the absolute value, if you integrate and get a log, you're going to make the problem much easier by doing so, and you don't get a benefit from your stupidity. You'll be out of a lot of points. Okay? So make sure you give that absolute value.
Ooh,
Les?
thanks.
Sure. Let me see where you guys are at. Are we ready to continue on or not yet? Are you done as you're going to be, or give us more? Done as you're going to be? Okay. So, what now? Exponentiate. When I exponentiate, what goes away? Not the absolute value? Not the absolute value. Okay? So that then tells me, oops, sorry, in both cases, 1 plus y equals, you didn't really need to do that, sorry, absolute value of x, sorry. Need to the, I didn't show that one. That's just pretty good, okay? Okay, cool, now what? Here's where things start to get dicey. Okay, so this is technique you need to solve. Say I went back to Algebra 1 with you. I told you the absolute value of something is 2. What do you know? It could be plus or minus 2, okay? That's crucial. When you dump the absolute value, when you lose absolute value, you consider the quantity could have been positive or negative. So if I dump this absolute value, I'm going to dump the left absolute value because y is what I want to find. 1 plus y could have been plus or minus the absolute value of x.
So you can move the plus or minus. So you don't do the plus or minus.
You don't. I'm not concerned with the absolute value on the x. I don't care. X can be whatever it wants. It's y I need to isolate. When I lose the absolute value on y, I consider it could have been plus or minus whatever's on the right side. Okay? That then is y equals negative 1 plus or minus absolute value of x. Am I done? No, not a function. Now you must choose. In order to force the point 1, 0, it would only be true, I'm just going to put that in, this is how I was taught. That would only be true if I put in an x, a y of 0, and an x of 1. This can only come out true if that is positive. Okay? So I will choose positive. Y equals negative 1 plus root, or not root, absolute value of x. Okay. That satisfies both conditions. It satisfies the differential equation condition and the initial condition, the initial point condition. Okay? How'd that go? All right. This is too much for the next little chunk of time. It's just a huge, another idea of differential equation, so it's just not coming up. I'll come back to it later, and that too. Where are we at on going over extra practice 85?
Not very far.
Not very far. This is just getting ridiculous. Where, and did we get through the mean value theory, kind of this?
We're still on 3.
We're still on 3 or C? 3. Okay, 3. Ben rides his unicycle. Yay. Okay, I can write a unit cycle, by the way. I just saying. Okay, one thing I'd like you to look for here in A, did you use a average rate of change over the interval to estimate? Acceleration is change in velocity over change in time. I can't take a derivative because I don't have equations. So did you do something like that? Look at your work. Do you have approximately or equal? If you have equal, you just lost a point on the AP test. It is an approximation. Okay? Make sure you are intentional about the approximation. Okay. B, notice again, this got me a million times. I lost, if you say equal, when you say mean approximate, you lose a point here, a point there, because you're approximating. Again, if you use a Riemann sum to estimate that integral and said it was equal, -1. It's not equal, it's an approximation. Okay, I'm not integrating, I'm using a table. What is that? Absolute value integrated. Velocity, absolute value integrated is? Distance. Distance is distance. Okay. Left Riemann sum, cha-cha-cha. Tell me this. Question unto you. Does the data in the table seem to indicate that the Riemann sum would underestimate or overestimate the true integral value? Why? Left Riemann sum on what appears to be an increasing function. Can't say for sure. Okay. Yes.
For integrating velocity, wouldn't that be distance? So like I used the v instead of the v's. So I did like 10 times 100 instead of 10 times 2.
10 times 100. Let me see what you're talking about.
Like I used the v of t's instead of the v of t's.
The V's, you should be using the V.
Okay.
Yes.
Just because that's in that question.
Right.
Okay.
Correct. Okay. Yes. Yes. I'm not going to go. Oh, shoot! Darn it! Darn it. Well, we'll get through it eventually. Test is tomorrow. Have a nice day. What? Yes, I removed the blocks and they're all online.
Oh.
Yeah, I reposted my key without them.
Maybe I'll have it finally here.
Yeah, the key is completely online. The recording is online. The test review is online. And that's all. Have a nice day.